You know, if you're making parts, you can make them by subtractive techniques, traditional machining, and these days you can also make them additively, 3D printing. Which is the better process for your part? Well, imagine if you could do both. I'm with Kevin Werkheiser, he's an applications engineer with Mazak. Kevin, I understand we're standing in front of what looks like a 5-axis mill, but in fact, this is a hybrid machine. Tell me about it.
Yeah, so we took our standard VC500 5-axis platform, and then we added a cladding head onto the side of it. So that cladding head now comes down when we need it. We do our additive machining, and then we retract it back up, come back in with a milling head, and machine it all in the same setup.
Now, it's, say your cladding head, in a sense, so I can build up a surface feature on top of a machine part? Yeah. And then can I come back in and machine off that surface feature?
Yeah, exactly. So now what we're doing is we're combining the ability to add features and material only when we need it, that you can do in additive manufacturing, but the drawbacks of that is usually accuracy and surface finish. So now with the milling machine, we bring back in the accuracy and the surface finish qualities that usually are needed.
And what kind of material options do I have for the additive part of the process?
So on this style of technology, we are capabilities of any steel, stainless steel, nickel, cobalt, and copper-based alloy.
Okay, you talk about nickel, you talk about some of the refractory high temperature alloys, like Inconels, that kind of thing?
Yep. Yeah, so a lot of problems with Inconel is the machinability of it. It's very slow to machine, it's also very expensive. So now what we can do is come in, only add the material where we need it, and now we're just removing approximately 50 thousandths of material at a time and getting what we need out of the part.
So you put a potentially temperature resistant outer skin on a lower cost
Yep,
part?
so now you have the ability of buy materials. So I can start with a cheaper substrate such as 1018 steel and then only add Inconel only where I need it, such as, like you said, a heat resistant coating.
How about wear resistance? So we think of hard surfacing applications which are sort of like that, like almost a plasma. Could you hard surface or coat with a more durable material on it?
Yeah, actually we're currently working with some customers on coating, such as I said earlier, 1018 steel with a D2 material on top of it for such things as die work. So rather than starting with a complete D2 part, you're only adding in where you need it, where you see the surface, where you see the wear pattern.
I guess those are some interesting possibilities. Historically, of course, if you have things like die parts, for example, you want a really hard, durable cutting edge, but it's also got to be ductile enough that it can take the hammering without cracking, and you get that heat treating issue. Sounds like maybe you could do something with a softer, more flexible core and then a harder cutting edge. Yeah,
it's something design engineers need to start thinking about to, you know, come up with new strategies of how to make something.
Now, I see that this is a Mazak Smooth X control. It looks very similar to the controls we see with straight up 5-axis milling machines. Is this a unique control for the hybrid machine?
Actually, no. The only thing inside of it is some additional PLC work. After that, programming the machine is just like a 5-axis machine tool. The only difference is now I have a few M codes for when I want to use my laser and my powder.
Now, many shops that use additive processes end up with a dedicated guy or girl who's the additive person, and then they're the one who know the technology, they can program it, they can make it work. CNC G-code people are a different breed, and they don't sort of meet. Because someone basically is used to programming in G-code and using 5-axis milling technology, can they now get a grip on the additive part of this?
Yeah, it's a good transition for them. So the type of toolpath is very similar already to what they're used to in their machining. The only difference is that now you need to know what to look for when you're actually building material on. So after some training, you start picking up on what you need to look for and how to carry that over into your next project.
And what industries do you anticipate will be early adopters to really take advantage of this technology? I think of aerospace would be one.
Yeah, aerospace definitely one. Defense companies as well, just because they have the resources to really invest in it. Another market I really see is rework. So rather than scrapping a very expensive component, you can now just add a little bit of material on where it wore out and then repurpose the part later on. Okay,
I mean traditionally things like crankshafts, for example, hard chroming and then grinding back to size in the technology. That kind of repair?
Yeah, definitely. That and like I was saying, die work. We were working with another customer that wanted to rework such thing as turbine blades or housings where it wears out after multiple use. And rather than scrap that component, try to put it back out into service.
Now, a traditional 3D printing, we can create hollow sections or complex internal geometry. Same thing applies here?
Yeah, but a little bit of limitations. We don't have the resolution that we do on the powder bed systems. So here your resolution is it's a little more coarse, so you're kind of limited a little bit, but at the same time, we also have some new processes that we can use because now I can manipulate the workpiece to only add where I need it, as opposed to a powder bed, which is strict 2.5-axis work.
Kevin, are design engineers going to have to rethink the way they design parts to use technologies like this?
Oh, definitely, especially to get the most advantage out of it.
According to Kevin Werkheiser at Mazak, hybrid, a technology that combines in many ways the best of additive manufacturing and 5-axis machining.